Hello, and welcome back to PNB Wellness Academy, where we make high-yield PMHNP board concepts easier to understand and easier to remember. If you keep getting agonists and partial agonists, antagonists, and inverse agonists mixed up, this video is for you. We're going to make it simple by thinking about the receptor like a light with a dimmer switch. Agonist equals turn it all the way on. An agonist binds to the receptor and activates it. Think about turning a light all the way up. A full agonist can produce the maximum response of the receptor system. So remember, agonist equals on. Partial agonist equals turn it partway on. A partial agonist also binds to and activates the receptor, but it has a lower efficacy than a full agonist. Think about turning a dimmer switch partway on. The light is on, but it's not at full brightness. Two high-yield examples: aripiprazole is a D2 partial agonist. Buspirone is a 5-HT1A partial agonist. Remember, partial agonist equals partway on. Antagonist equals block the switch. An antagonist binds to the receptor but doesn't activate it. Instead, it blocks a neurotransmitter or agonist from activating that receptor. Imagine putting a cover over the light switch so someone else can't turn it on. That's your antagonist. Antagonist equals blocking. A high-yield psychiatric example is D2 receptor antagonism, which is an important mechanism of many antipsychotic medications. And then lastly, we have the inverse agonist. It turns the baseline activity down. Now here's the one students often struggle with. Some receptors have a small amount of baseline activity even when an agonist isn't bound. An inverse agonist binds to that receptor and decreases its baseline activity. So an antagonist blocks activation while an inverse agonist actually pushes receptor activity below its baseline level. Remember, inverse agonist turns the baseline activity down. So let's do a quick review. We're going to put all four together. Agonist, you're going to turn it on. Partial agonist is partway on. Antagonist is being blocked. Inverse agonist, you turn the baseline level down. So when you see one of these on the boards, don't panic over the definition. Just ask yourself, what is happening to the receptor's activity? Once you can answer that, these concepts become much easier to separate. Let's try some quick review questions. A medication binds to a receptor and produces the maximum biological response of that receptor. Which term best describes this medication? A, antagonist, B, partial agonist, C, full agonist, or D, inverse agonist? C, full agonist. Why? A full agonist binds to and activates the receptor with sufficient efficacy to produce the symptom's maximum response. Question 2. Aripiprazole binds to D2 receptors and activates them but produces a lower maximum response than a full agonist. Which receptor action best describes aripiprazole? A, full agonist, B, partial agonist, C, antagonist, or D, inverse agonist? The answer is B, partial agonist. Remember, partial agonist equals partway on. Question 3. A medication binds to a receptor but does not activate it and prevents an endogenous neurotransmitter from activating the receptor. Which term describes this action? A, agonist, B, partial agonist, C, inverse agonist, or D, antagonist? Answer is D, antagonist. Remember, antagonist equals block. Question number 4. A drug binds to a receptor that has a baseline activity and reduces the receptor's activity below its baseline level. What type of drug is this? A, an antagonist, B, an inverse agonist, C, a partial agonist, or D, a full agonist? The answer is B, inverse agonist. Remember, inverse agonist turns down the baseline. Now, if you got all four, you've got the concept. Remember, on, partway on, block, turn baseline down. Thank you for listening with PNB Wellness Academy. Join us for more tips in the future videos.